Let's get going now. So I want to start by saying that there's truly no limit to what people can achieve when the technology that they use kind of matches their abilities. For us at Microsoft, accessibility has been a top priority across pretty much all of the devices, products, and platforms that we produce. The web browser being both a platform and a product kind of requires extra attention to accessibility. Hearing, mobility, learning, neurodiversity, there are many different types of accessibility that we strive to address and improve. And today, we'll focus on what it takes to provide great experiences for people with low or no vision. So, now that I have this dramatic intro out of the way, let me tell you how I came up with the name of the talk. Right? I have 2 points that I want to make here. Many of you probably recall Steve Kobe's talk about life of a pixel. It's a great primer for people who are coming in on Blink platform like ourselves. You go and pretty much within 30 minutes you get all of the concepts of how things are supposed to work, and then you go and start working, and then you find out that that's already outdated after a year, but that's fine. In general, concepts are still the same. So that inspired me. I'm like, well, let's try to do something similar that will talk through the accessibility pipeline and see what that kind of presentation framework looks like. And so the first thing I wanted to say is that this is how I came up with the name, where Steve did a great job explaining the magic in the middle that takes content to pixels. And I'm going to make it without pixels and kind of what it takes to produce the same thing with sound. The second point I wanted to make was that when I picked the name Life Without a Pixel, I didn't intend to refer to any products of any company. Because I was thinking about this on the way here, I wanted to make sure that there is no connection between my talk and any of that. Being my first BlinkOn talk, that would have been kind of weird. So, my name is Rossen Atanassov. I'm an engineer on the core web platform on Microsoft Edge. And today I'm joined by Kevin Babbitt, who is also an engineer working on, among other things, accessibility. And he's going to start by walking through the architecture of Chromium, and then I'll talk about some more fun things.
All right, thanks, Rossen. Morning.
Morning.
Okay, so I'd like to start by laying out exactly what it is we're trying to do here. Now, an assistive technology, such as a screen reader, views the world as basically a tree of nodes, regardless of whether the application that's being used is a text editor, or spreadsheet, or a web browser. Each of these gets represented to the assistive technology as a tree of nodes. And now, each of these nodes contains a collection of properties that allow the assistive technology and the user to do anything that a user not reliant on these technologies would do. And one of the most important properties for a node is its name. Now, for a piece of the browser UI, typically the name will be a short textual description of the control. For example, for a button, when you hover over a button, you get a tooltip. That text would make a good name for the node. For web content, typically the name of a node is going to be the textual content of the corresponding node in the DOM tree. Now, generally, a screen reader wants to present text in a way that's natural to the user. For example, one sentence at a time. But when you have heavily markup content like on Wikipedia, like I mentioned, the text tends to be broken up along the boundaries of DOM nodes, and that presents some interesting challenges that Rossen will talk a little bit more later on. Another important property is role. Now, role describes the type of an element. It could be a button, a hyperlink, structural components such as a table, or simply a piece of text. And this gives the assistive technology and the user clues as to how they can interact with that particular element. So the first thing that we're trying to do in the accessibility pipeline is produce this tree representation of everything that's going on in the browser. Additionally, as users, we don't just read web pages, we interact with them, and the accessibility APIs on each platform provide a set of methods that can be called to invoke actions such as clicking a button, manipulating a scroll bar, opening a select control, and selecting an option from it. So we need to respond to these actions when they're triggered. And finally, modern web pages are very dynamic, and so when content changes, we need to notify any application that's listening that this change has occurred, or there's this notion of a live region, which can provide a continuing update on a web page, and we need to make sure that those notifications get out. Now, we don't do any of this work by default, and the reason for that is performance. There's a lot of work that goes into gathering the information that populates the accessibility tree, and while it's very important that we do that work for the users that are relying on it, if there's no consumer of this information, we don't want all that work to be in the way of everything else that a browser needs to do. And so all this functionality is dormant until an assistive technology comes along and asks us for a tree. Now on Windows, there are a couple different APIs that an assistive technology can use to do this. Microsoft Active Accessibility is an API introduced in about 1997, has a support for a fairly basic set of properties and actions such as clicking a button and so on. iAccessible 2 builds on MSAA to introduce support for structural content, hyperlinks, and a few other things. And both of these APIs are implemented in Chromium today. Oh, and with MSAA and IA2, typically the assistive technology will inject a component directly into the browser process in order to talk directly to the accessibility representation. UI automation is the modern replacement for this on Windows. It's intended to leave some of the design decisions that made sense in 1997 in the past, and also introduce support for rich reading of text and additional structural patterns. We're working on implementing this today in Chromium. And another important difference with UI automation is that the operating system acts as a broker between the assistive technology or the client and the provider, such as the web browser. And this also introduces some new opportunities, which Rossen will go into later on. Now, regardless of which API is getting called, the request for a tree comes into us in the form of a window message called wm-get-object. And when we get that message, we'll do a few things. The first thing we'll do is we'll start to wake up the code that's responsible for producing the accessibility tree. And we'll progressively wake up additional portions of that subsystem as we start to get API requests for specific information. So we'll start that system up, and we'll return an object representing the root of our accessibility tree. And then from there, the assistive technology can start exploring the tree, querying for information, and so on. So next I want to talk about what happens when we start to wake up that logic. Once the assistive technology has indicated that it's interested in information in the web page, we'll start by sending an IPC message across, which will set one of a series of flags in the renderer process to indicate that we started requesting accessibility information. So when that flag first gets set, we generate a layout complete event, and from that point forward, any layout complete event, whether it's due to a state change or just a simple navigate in the renderer, will cause us to collect the latest state of accessibility information and package it up, and I'll go through that shortly. Now, the information we're gathering here comes from a couple different places. Some of it is simply attributes in the DOM. This will be things like control types, states, values in the text field, and so on. We'll also gather attributes from a standard called ARIA. Now, ARIA is a standard that allows a web author to override the default accessibility representation of a given element. So, for example, if we built a checkbox using divs in JavaScript, without ARIA, to a screen reader, that'll just look like another div. And with ARIA markup, you signal to the assistive technology that this should be treated exactly the same as a native checkbox. So we'll gather the attribute information. We'll also gather information from layout. This includes text, and the reason we gather text from layout is to make sure we include generated content. Some assistive technologies will want to iterate content line by line, so we'll gather line break information. And we'll also gather some information from computed style. For example, if there's bolded text, the assistive technology might want to read that with greater emphasis, so we'll get that information as well. All of this information is gathered up by a couple classes here. LinkAX tree source is the class that basically for each node that needs to be serialized and sent over, we call this function, and that in turn calls AX layout object. AX layout object is a class that on one end it just has a series of getter methods that express accessibility concepts like name, role, control state, and so on. And it doesn't store any data, it simply implements these accessibility getters in terms of what's in the DOM and layout and computed style. So we gather that information up, we check to see what's changed since the last time we synced so that we don't send up the entire tree every single update. And then we serialize all this information into a structure called AX node data. And this is a very simple bag of property value pairs that's designed to be serialized and sent back up to the browser process. We package these node data structures into an AX tree update. We generate one of these per frame, and we send it back over IPC to the browser process. Now, when that information arrives in the browser process, it gets handled by a class, it gets received by a class called Browser Accessibility Manager. And again, we have one of these per frame, and this is responsible for maintaining the accessibility representation in the browser process that corresponds to the corresponding frame in the renderer. It will call a helper method called AXTreeUnserialize to unserialize the information it got and apply it to an AX node, a tree of AX nodes in the browser process, representing the corresponding frame. So now we still need to get that out to the platform APIs so that assistive technologies have this information. And there's the objects implementing the platform APIs are just called AX platform node, and there's one of these, there's a subclass there for each supported platform on Chromium, so Mac, Windows, Linux, etc. But the platform node doesn't talk directly to the AX node structure, and the reason, once again, is views. We have to represent the browser UI as well in our accessibility tree. And so to do this, the platform node talks to a delegate interface, which has the same implementation. It's an abstraction implemented both by browser accessibility for web content and View AX platform node delegate. There's a lot of classes that are mouthfuls in this area for Views UI. And so with this architecture, we have one class that knows how to implement the platform APIs, regardless of whether we're doing so for web content, for browser user interface elements, or anything else that's happening in Chrome. And so with that, we have sort of an end-to-end picture of how information makes it from a web page all the way out to a screen reader. First, the assistive technology asks for an accessibility representation. We get that request, we start gathering information from the DOM and layout trees in the renderer. We send that information over the process boundary to the browser process. Then in the browser process, we implement platform APIs that the AT can use to walk the tree, retrieve information, and render it to the user using speech synthesis or some other technology. So the last thing I want to touch on is how you can take a look at what's in the accessibility tree. Chrome://accessibility it works on all platforms. It can show you either the internal representation that we generate for web content, or it can show you the tree the native accessibility tree on the platform that you're on. These checkboxes up here, I mentioned earlier that we sort of progressively enable accessibility state depending on what's been asked. These checkboxes let you enable and disable those modes manually. And if you're on Windows and you want to see what exactly an assistive technology is seeing when they query the tree, there's a set of tools in the platform SDK that you can use to do that. If you've ever built Chrome on Windows, you already have these tools, and the link on the slide will show you where to find them exactly and how to use them. I'll just go through them real quick. Inspect is probably the one you're going to want to use the most. Basically, you start it up, mouse anywhere really on your desktop, and it will jump to the corresponding node in the accessibility representation and show you all the properties that are on it. And from there, you can walk the neighborhood in the tree. You can also invoke action APIs just to make sure that they're working correctly. ACK-Event is another tool. It's simply a logger for accessibility events. You choose what scope you want to listen to, either a given application or the entire system, and the set of events you want to listen to, and it just starts logging them. There is also an accessibility checker, which allows you to point at a window and run a series of basic checks for things like tree consistency, missing properties, and that kind of thing. And so that's a quick walkthrough of the entire pipeline, and so I'd like to hand it back to Rossen to talk about some ideas we have for improvements.
All right, cool, thank you. So, hopefully now that we appreciate some of the complexity that goes into building accessibility, the first thing that I wanted to touch upon was ideas about how to improve performance. Now, because we're not drawing pixels, that doesn't mean that performance doesn't matter. Any of the subsystem sound APIs or audio APIs within 50 millisecond time frame is usually critical for people who are perceiving content through audio output, or even if it's tactile display like a Braille, these updates should still be just as performant. One thing this is mostly like a reflection based on some of the previous experience that we had building accessibility for our Windows 10 Microsoft Edge browser. And there, because UI automation, like Kevin said, acts as trusted system process broker, we are able to separate the different providers from all of the different processes. That includes the browser process, render processes, plugin processes like PDF. PDF also needs to be accessible, and basically minimize the amount of information that gets produced and bunched up and sent back over to the API mappings. This produces really important opportunities because usually, more often than not, users are focusing on one thing at a time and they don't care about everything else around. So building the entire tree is not necessary. So that was kind of the motivation. In here, I'm repeating some of the things that Kevin already said, but assistive technology would interact with the API. And on its turn, if we allow per process provider information, then we can really scope the type of trees that we produce and build and the amount of information that we need to update with every change. To the user, this still needs to make sense though, right? They still need to be able to go and be able to walk all the way back to their desktop. And so the way UAA handles this is the different providers. Oh, I pressed a button that somehow hid my slide. There we go. I need to remember that shortcut for emergency. So in here, basically the idea is we create these little baby trees, like these are like baby trees, not like the previous ones were big, these ones are tiny. We send them over to UAA, and now UI automation itself or other mappings have enough parent-child window relationship to be able to stitch all of the different routes, and they are the ones who are propagating and updating and actually building the entire tree. Now, again, this tree is tiny compared to the other one because it only has pretty much the skeleton of the thing that the user is interested in. And then from there, the same thing goes on. Information goes back to assistive technology, and then they are hitting some sort of output device. Now, the next thing I wanted to do to talk about is text. Text, as many of you here probably on the platform team know, is kind of hard, and it also means many things to many people. So let me talk about what I mean about text. For the purposes of accessibility, more often than not, the way people perceive and consume text is in one-dimensional way. They want to be able to start reading somewhere and then start advancing based on some sort of predefined coarseness of the text, whether it be a line or a paragraph. Or maybe they're editing and they want to go back and forth and make sure that they spelled something correctly, so they're going to go back on character level and then just advance back and forth in character. But now, what does all these things mean if I create a range? Most accessibility APIs allow us to create a range. And I say, give me the range of text for the body of some page, like this one on Wikipedia. The information here is super loaded. There is bold italic, there's hyperlinks, there are superscripts, subscripts, table, inline images, the web, basically. And so taking all of this and saying, oh, and the string that represents all of this is block, like inner HTML or something, not really, or text. It still has to have this rich, to preserve its rich semantic. It needs to go and emphasize the word needs additional citations because it's bolded, right? And so this information, again, I'm reflecting a little bit on something that we built in the existing Edge browser, which was, we looked at this problem for some time and said, well, look, again, text is hard. It looks simple on the screen, but it's difficult internally. So we created a couple of different abstractions that allowed different users and different services to plug in and basically use text in a kind of ubiquitous way. So we had something called, let me just touch upon this. And the point here was that what comes down on the wire is a piece of markup, takes many transformations, right? DOM will take it and will basically break this text into a bunch of nodes and text nodes. Layout is going to read this and go and position a bunch of glyphs on the render surface. And then editor or accessibility will want to have this kind of one-dimensional view of everything that's there. The base construct that we created was something called text position, or we also sometimes refer to it as a symbol, which allows you to navigate the tree through this abstracted way, but move as if it was a simple kind of linear structure. And the symbol, this symbol concept was rather straightforward for some things. Like, for example, a character was just a character. Well, sometimes you have UTF-16, so it's just more than one. So as you're advancing in the content side, and you want to say, give me the next, what appears to be a character on the screen, you might actually go through 2 code points. New lines are super hard. Being able to abstract them correctly is a pain. Again, having such concept allows you to skip over a whole bunch of tags that from point of view of text have no meaning. Besides saying, oh, you went to a new line because you crossed a whole bunch of block elements and whatnot. And finally, of course, we have complex things like form controls or images and whatnot. They still need to be represented, but just kind of skip over. So this is something that helped us really kind of stand up accessibility, but also improved our editor quite a bit. It was something that allowed this easy manipulation of inserting and splicing and doing all of the regular kind of operations of editing in a kind of predictive way. All right, the last thing that I wanted to touch upon was I wanted to highlight some of the ideas around process model. In there, again, as we've already seen a number of times before, current picture is more often than not, the browser process will allow third-party processes to inject in proc and consume the accessibility tree information directly. But this is the big tree that I was talking about. It has big trees in here. And so by doing so, we are allowing code that we believe it's trusted, but is it really? We have seen this being an attack a vector of attacks, and people, going in your process and then parting in there. One simple idea was, well, can we start by isolating the accessibility tree in its own process? If you think about what goes in here, all of the different providers, now the browser will become a provider on its own to build this tree. It will, for the purposes of views and auto UI, will still produce trees and send them over. But as a starting point, we can break this thing out in its own process, isolate the browser process entirely. At this point, there's no reason for you to get inside of the proc. And then allow, for the time being, process injection for the accessibility process alone. Now, the accessibility process has a bunch of data, so good luck. Like, there's not much you can do there, ideally. And then further down the road, as implementation catches up with the more modern APIs, we can think about isolating even the accessibility process alone, so it's still a trusted process and everything gets communicated over trusted API. All right, so with that, I'm going to take all the pixels away from the screen and open for Q&A. Oh, and thank you. Yes.
So I think you said that there's about a 50 millisecond sort of frame deadline, if you will, for audio and braille sort of readers. Do we have any data on whether we hit that, basically? Like how often people don't make the deadline?
Yeah, so that's an awesome question. If you chat with some of the third-party AT vendors, like I've spoken to Mick, I forget his last name, he's one of the two guys who started NVDA. And they are one of the examples that they inject in process, they interrogate the entire browser tree and create their stations. And currently, I've been told by him that this is possible. Now, when you have a broker in the middle, things get, like UI automation, for example, things will get slowed down because you have a couple of extra indirection points. Now, the good news is there that these same people from NVDA and other AT vendors have worked extensively with the Windows accessibility team, and they have provided a bunch of different mechanisms where UI automation on its own is going to make those guarantees, and now they're very already experimenting with these APIs, and they're hitting these expected frame buffers. Yes, I don't know who went first. Go ahead.
There's a privacy worry about sites being able to detect that users are using assistive technology.
Yes.
How well are we doing at preventing them from knowing that, and does UI automation improve things?
Yeah, so this is awesome. So I think at least it is our belief that privacy is a basic human right, and we care about privacy deeply. Things like ARIA and all of the declarative layer accessibility was designed with that exact thing in mind, so that when you're providing information is not observable. So in one of the first slides that Kevin covered, it should have been kind of easy to pick up that essentially you're creating a read-only view that's exposed to the accessibility layer. And then from there on, the main thread, or the UI thread that we call, has no access or way to detect that you are providing all of this information.
I was thinking of timing attacks because you said it's expensive to generate the accessibility information.
I honestly don't know if timing attacks are a problem or make it detectable.
That's a fair question, because the gathering of, I'm actually not sure if the gathering of the information happens on the main renderer thread or not. That'd be something that'd be interesting to look at. Mm-hmm. And that obviously would be the way that you would detect it.
Well, yeah. A lot of the API calls have synchronous expectation, but that's why the tree is already built. So they mostly operate against that tree, and it's up to the renderer or any other provider internal process to update things as they go. So I don't believe that this is going to be a...
Yeah, and then one other thing that I forgot to mention is that when the action APIs call in for web content, we map those to exactly the same construct as if the keyboard and mouse user had generated this information. So for example, an invoke action on a button will be just generated to a normal JavaScript on-click event. And so from that perspective, there's no way to detect, for a web page, to detect that an assistive technology API has been called.
I think there was...
So my question was actually kind of related to that. I was going to ask if there is any communication in the other direction, for like clicks and things like that. Is there any information that the assistive technology gives to like where the user is in the page, or like what the user is kind of interacting with?
Or is that possible?
No.
No, actually. I mean, the screen reader will typically maintain its own internal state of where in the navigation it is. And for anyone who was at the spatial navigation talk yesterday, there's a sort of differentiation in that space between interest and focus. And so a screen reader will typically have this notion of interest, which is the element in the tree that it's currently looking at. But, I mean, it's just as if you were scanning with your eyes. I mean, the web page can't yet detect where you're looking.
Yeah.
So.
I mean, could you have something like a pointer event or like a hover, for example? Like,
So if something is hoverable, it will have a behavior that says I'm hoverable, and then the AT or whoever is using this will activate this behavior. And so that's how. And then whatever the implementation internal is, if it's supposed to generate a pointer event or click or what have you, will take effect.
okay.
You had a question?
I was just wondering, have you run into, like when you talk about text generation from bone structures, have you run into more like statistical models rather than heuristics in terms of either learned models or more models that use natural language understanding for summarization or question answering? Like how much have you run into experiments on more statistical models than the deterministic ones?
Nothing comes to mind. Yeah, perhaps it's an interesting thing to come join us and help maybe. So there were a couple of questions back. Rick was, and then Steve was Steven, yeah. And then Julie.
Maybe continuing along that line.
What time do we have to finish, by the way?
You finished 5 minutes ago, there's 5 more minutes till the next one.
Okay, so let's make those three hopefully observations quick.
Have you thought much about the continuum between like a no vision user and a user
Yes.
who's using like something like a home speaker, right? A Google Assistant or something
Yes,
like that?
yes, absolutely.
It seems like there's some overlap, but they're different in that in the one case you can train the user to use something that's very deep and efficient. The other one, it's got to be maybe more.
So this is
that's
one of
what I wanted
the
to-
it is super it is a super interesting area. Being able to naturally say to like I should be able to tell my browser go to Facebook. Good luck today. I mean that should be doable.
I should be able to tell my browser,
open a new email. Steve.
I did not think mine was a quick remark, so I was curious about why an accessibility process. I didn't quite understand what the benefit of a separate process for accessibility was.
Just one benefit is better sandboxing for the browser process.
Okay.
So I think from what I understand, assistive technology are one of the last processes to be allowed to inject inside a browser process. So if you have no third-party process injection, that is based on experience that we had with Edge, where we just kicked everyone off. We had least privilege app container, and then everyone had to go and communicate.
Okay. That makes a lot of sense.
Johnny?
I was going to ask if there's, like, you mentioned that there's an inevitable cost in ramping up the accessibility code, et cetera. There's obviously a spectrum of needs with users, but at one extreme, you could also potentially ramp down the sort of GPU layer and so forth. And I'm curious if that's considered.
Not to me. It's a great idea.
There's some devices that don't have like GPUs and screens.
Yeah,
Of course, yeah.
there's certainly output devices that are just tactile, for example.
I mean, they're like computers without screens. It's really purposely built.
Okay, we are out of time. I don't want to hold everyone else. Thank you.